Now let's imagine I want to convert a mixed number into an improper fraction. Well, how do we do that? Well, first we need a mixed number. So let's come up with a number like 3 3/4. How do we convert that to an improper fraction? Well, there's many ways to do that, but one way I like to do that is to develop a picture to help me understand what's happening. So here's my picture. I have to understand that there are 3 holes in this, and I have a partial hole. So let me draw this partial hole. For example, I'm going to make a circle. There's 4 parts in the circle, and I know that I have 3 of them filled in, or I have 3 parts of those 4. Now these other 3 that I have, well, I'm going to make 3 full circles, and likewise divide them up into groups of 4. And each one of those spots is accounted for, so I'll put a little dot in each one. And that's my picture. So my next step I'm going to do is, well, I'm just going to count up how many parts of 4 do I have? How many fourths do I have? Well, I have 4 plus 4 more, plus another 4, 4 plus 4 plus 4, plus in that last one, I have 3. So I have a total of 15 fourths. Now some of you might be thinking is, wait a minute, there might have been a quicker way to add all those on up. Because I notice that the first 3 all have 4 in it. So there's a multiplication problem right there waiting for me. I can have 4 times a 3 plus the 3, and that equals 15. Now do you see that anywhere else in the problem where maybe I could have come up with that? Well, sure. I see within this algorithm, or within the mixed number, there's an algorithm embedded in that, where I can take the denominator, which is a 4, times the whole, 3, add the leftovers, which is another 3, 4 times 3 plus 3 equals 15. All right, getting a sense, getting a good feel of this? Well, let me give you a second, and let's try one more just to see if we got the hang of it. So let's look at something like maybe 7 1/6. How should we think about that? Well, I'm going to draw a picture first, and then I'm going to use the algorithm after that. And I hope we can get to the same answer both ways. So let's draw a picture first. I'm going to look at the partial. So I see I have 1 part out of a 6. So I'm going to try to draw a circle with 6 parts in it. And one of them is filled. Now I have 7 more circles, or 7 more holes I'm going to create. So 1, 2, 3, 4, 5, 6, and 7. And each one of those I want to likewise divide up into parts of 6s. Then what I'm going to do with all of those, I'm going to make sure that all of those are filled. So there's 1 there. They're all filled. I have 2 more. I know how many are going to be in there. There's going to be 6. So maybe I'll just put a little 6 in there. So what I'll do now is I'm going to add up all my parts of 6s. So I have 6 plus another 6 plus another 6 plus another 6. Or maybe I'm going to use multiplication here because I don't want to skip count by 6. I want to use a multiplication fact. So I have 7 groups of 6, which is a 7 times a 6, plus I have 1 more parts of 6 at the end. So what's 7 times 6? Yep, you're right, 42. Plus that 1 equals 43. So altogether, I have 43 parts of 6s, or 43/6. So my improper fraction, 43/6, is the same thing as my mixed number, 7 1/6. So that was my picture. Now I can also remember that there was an algorithm involved as well, which told me I could take the numerator multiplied by the whole, 6 times 7, add the leftover, which is the 1. 6 times 7 is 42, plus 1 is a 43, over the 6. And you can see both ways I got the same answer. And the reason why? Both ways is telling me to do, or both ways I was doing the exact same thing. I hope that helps a little bit with you guys.